Hi, welcome to the video solution for Cambridge Physics past paper. This is IGCSE Physics Summer 2019, paper 22, and in fact, this is second video for the series. So let's start. Question number 21: which condition are necessary for light to be totally internally reflected? So remember, whenever they talk about total internal reflection, so the ray of light should be entering from a high refractive index medium to the low refractive index, or from a dense medium to light or rare medium. So suppose the light is coming from glass to water, or maybe air comparatively. So if light is coming from glass, something like this is the ray of light, and then when it enters, it bends away from the normal because it is the refraction from denser to rarer medium, or from high refractive index to low refractive index. So it will bend. This is the normal, and the ray will bend away from the normal, something like this. So the first condition for total internal reflection is the light should be traveling from dense to rare, and incident angle, this is incident angle, should be greater than critical angle. These are the two necessary conditions for light to be totally internally reflected. So if you see the less dense the incident light is in no, so less dense options are gone. More dense, yes, light should be in more dense medium. C and D are okay as per first column. Angle of incidence, so less than critical angle, no. Angle of incidence should be greater than critical angle for total internal reflection. So your option is D. The light, okay. Light is traveling through air. It strikes a glass block at an angle of incidence of 45 degree. The glass has a refractive index of 1.4. What is the angle of refraction of the light as it enters the glass? So you are given incident angle I and refractive index N, and light is coming from air to glass, and you need to find angle of refraction R. It is a straightforward question. Refraction from rare medium to dense medium, or less dense to more dense, or low refractive index to high refractive index. You have formula, or you have a relation, n is equal to sine I divided by sine R. So you can rearrange this equation for R. So you have sine R is equal to sine I divided by n, and sine of 45 divided by 1.4. If you solve this number and take the inverse of the sine, so R would be equal to 30.3 degree. So you rounded this off to 30, so your option is B. 23. An eclipse of the sun happens when the moon comes between the earth and the sun. Which statement is correct? Infrared radiation from the sun disappeared before visible light and ultraviolet radiation from the sun disappeared before the visible light, and infrared visible light disappear before ultraviolet and infrared ultraviolet and visible from the sun all disappear at the same moment. This question is all about uh, diffraction process or diffraction phenomenon. What is diffraction? Diffraction is spreading of a wave or bending of a wave around an obstacle. So if you see, moon is coming in between earth and the sun. So in fact what happens, suppose this is the sun and this is the moon. So light coming from the sun is stopped by the moon. So basically moon is an obstacle that is blocking the way of waves. Light is waves, and light or waves after passing any obstacle they diffract. If they diffract, so they bend from their path. So diffraction is all about relation between size of the obstacle, size of the obstacle and wavelength. So if wavelength is equal to size of the obstacle, then we have a maximum diffraction. Or wavelength if is smaller than the obstacle, so wave um, all waves are passed. But if wavelength is greater, then it cannot pass through. So you see that the size of the moon is much greater than the wavelength of all the radiation discussed in the question: ultraviolet, infrared, and the visible light. So size of the obstacle is greater than these, so all the lights are stopped at the same time. That means your option should be D. It's all about because the wavelength is much smaller than the size of the moon. That's why all the radiations are stopped. Question number 24. A pulse of sound is produced at the bottom of a boat. The sound travels through the water and is refracted from a shoal of fish. The sound reaches the boat again after 1.2 seconds. The speed of the sound is 1500 meter per second. How far below the bottom of the boat is the shoal of the fish? Okay, so it's all about pulse and echo question. A typical pulse and echo. So what happened? Sound waves goes down and then after reflection it comes back. So this is pulse and this is echo. And remember, for the pulse and echo we use formula for speed. D is equal to Vt, where D is the distance traveled, V is the velocity, T is the time. But in this case D is in fact twice. 2D is equal to Vt. Why? Because if the distance is D, then the sound waves is taking D distance or covering D distance when going and D distance when coming. So basically the total distance is double of the one-sided one. And the most common mistake generally students do, they forget to put this 2 in the formula. So you need to find the distance D. So D is equal to Vt divided by 2. That means velocity of the sound is 1500 and time is 1.2 second divided by 2. And if you solve this question, sorry, if you solve this fraction, then you have option 900. That means your option is B. Question number 25. An observer stands at a fish line of a 100-meter race. He wants to time the winner's run. He starts his stopwatch as soon as he sees smoke from the starting gun, instead of when he hears the bang. What is reason for doing this? Light travels much faster than sound. Indeed, if you see, this is again a typical question of comparing speed of sound and speed of light. So speed of light is much higher than the sound. That's why he is starting the timer when he sees the smoke. That means the light. So option should be A. 26. A soft iron bar is a long way from any magnetic field. How can the material of the bar be described? An iron bar is long way from any type of magnetic field. Okay, so it is magnetic and strongly magnetized? No. Yes, because it is made of iron, so the material is magnetic, but it is not magnetized because it is away from any types of magnetic field. So it is magnetic, but it is not magnetized. So option is B. C and D, you don't waste time on C and D because they are saying it is non-magnetic. Now, iron bar or iron is a magnetic material. That's why it is attracted by the magnet. So it is magnetic material. So C and D is immediately gone. You need to think about the difference between A and B. So both are magnetic material, but because it is away from any magnetic field, so it cannot be magnetized. It is unmagnetized. Your option is B. Question number 27. Diagram 1 shows two thin uncharged strips of plastic. Diagram 2 shows the same strips after they have been rubbed with a dry cloth. Diagram 1, okay, normal position. After rubbing, they have this position. Of course, you know that when something is rubbed or some object is rubbed, then due to rubbing, we have a static electricity produced or transfer of charges from one object to another. That means what is happening when you are rubbing these plastic with the dry cloth, both of the plastic gets some charges. And what type of charges the strips are getting, we can see the difference between these two diagrams. That both of the strips are moving away. That means these strips are repelling each other, so they must, both of the strip must have same charges, and they are repelling each other. So they cannot have opposite charges, because if they would have been opposite charges, so they should attract. So they have the same charges, either option C or D, but it's not due to attraction, repulsion. So option is D. '28. A cell has an electromotive force EMF of 1.5 volt. What does this statement means? The cell converts 1 joule. No, 1 joule. You just don't waste time when you see 1 joule, because it should convert 1.5 joule, 1.5 volt. 1.5 volt means 1.5 joule per coulomb. If you see the formula for EMF or formula for voltage, V is equal to energy per unit charge. So 1.5 volt means 1.5 joule per coulomb. So one cell convert 1.5 joule energy when driving 1 coulomb of charge. Indeed, it should be the option. Let's see this option C. The cell converts 1.5 joule energy per. There is no sense of timing, so you cannot have C. A. D is the cell converts 1.5. It is all about power, not the energy. So you cannot have option D. But B, the cell converts 1.5 joule for 1 coulomb of charge. So option should be B. 29. A metal wire of length 100 centimeter and cross-sectional area of 0.2 millimeter square has a resistance of 8 ohm. Okay. What is the resistance of the wire of the same metal of length 50 and cross-sectional area of 0.4? So you need to find the resistance. Okay, let's call it L1, A1, and the resistance R1. And this is the same metal, length L2, area A2, and that means you need to figure out R2. So if you know it's all about one important concept, length and area linked with the resistance. So we have a concept of resistivity. The resistivity rho is equal to R A by L. So that means if you take the ratio of resistances, so you can say that you can make R as a subject. So R is equal to uh, rho L upon A. So if you say this is resistance of the first metal, R1 rho L1 A1, and R2 would be equal to rho L2 A2, because resistivity is the same because of the same metal they are using. So I can take the ratio between R2 and R1. So R2 divided by R1. So R2 is rho L2 divided by A2 divided by, this is R2 divided by R1. R1 is rho L1 divided by A1. So rho gets cancelled. And if you simplify this fraction, you would have L2 divided by A2 into A1 divided by L1. Substitute all the values. So L2 is 50 divided by A2. A2 is 0.4, which is this, times A1 0.2 divided by 100, meaning 50 times 0.2, you would have 10, and 100 times, so 40. That means 0.25 or 1 upon 4. So you have a ratio R2 divided by R1 is equal to 0.25, and send R1 on the other side. So R2 would be equal to 0.25 times R1. So R2 is 2 ohm because R1 is 8. So 8 multiplied by 0.25 will give you 2. So answer is 2 ohm. So your option is A. Or this approach can be used because only length is changing. So you can say the ratio between resistance, length and the area is always same. That's what I use R2 upon R1. Sorry, it's R1. 30. The diagram shows a circuit. What is connected in parallel with the thermistor? So if you see thermistor, this is basically question they are checking your uh, you know um, memory, or whether you know the circuit symbols or not. So this is variable resistors, this is a light dependent resistor, and this one is thermistor. So parallel to the thermistor is this one, and this is heater. So option is A. 31. A lamp is to be connected in a circuit to so that the potential difference across it can be varied from 0 to 6 volt. Which circuit would be most suitable? It's all about the circuit of potential divider or circuit of rheostat. If you see the options A, B, and C and D, so you don't waste time on C and D thinking about C and D, because in C and D voltage of the bulb cannot be changed because we are using constant resistance or fixed resistor. No matter what you do, voltage cannot be changed in D as well as in C. So C and D options are gone. only you need to think about A and B. In a variable resistor is using, in which we are using parallel bulb, but in fact this variable resistance is in series with the uh, power supply basically. So this variable resistance will change the resistance, but not from 0 to 6. This one is basically a potential divider circuit, and this symbol is a symbol of rheostat. And if you recall your theory, and you see this is the rheostat. So in a rheostat you have three terminal 1, terminal 2, and terminal 3. If you use terminal 1 and 2, or terminal 1 and 3, if you use these two terminal with connecting with the power supply, plus and minus, meaning 1 or 2 are connected directly, 1 and 2, something like this, that means this is connected in series, and this rheostat will behave as a rheostat. Sorry, it is rheostat, but it will behave as a resistor, variable resistor, or current controller, we say. There is another option, we use all the three, 1, 2, 3. We use all the three terminals in the circuit, so that the rheostat behave as a potential divider. So this 1 and 2, 1 and 2, or 1 and 3 are connected with the component, like in this case the bulb, something like this, and this one goes to the power supply along with the connection going with the battery, something like this, if you are understanding, I hope so. So now the bulb is in parallel with this. So remember, if you are using only two terminals, 1 and 2, 1 and 3, then it is a current controller, or the rheostat will be behaving as a variable resistance. But if you are using all the three terminals and the component in parallel, then the same rheostat behaves as a potential divider, and the voltage can be varied from 0 to 2. So your option is B. 32. The circuit below can be completed by inserting component at X and Y. The completed circuit is a potential divider in which the potential difference across component Y increases. Potential difference across the component Y increases when the temperature increase. So it's all about two things. Whenever they are saying variation of potential difference or variation of resistance with respect to temperature, that means there must be involvement of thermistor. So most of the time of temperature and thermistor. So which row shows the component X and the component Y? So of course it's all about temperature change. So we must have a thermistor. So option A, thermistor is not there, cannot waste time. Option B, thermistor is not involved in the option. So A and B are immediately gone. We need to think about C and D, because in both options we have thermistor. Either Y is a thermistor, or D is the option D, thermistor is X. So we need to choose the correct position. Now what if I say we are using thermistor at Y? Here, if I use thermistor at Y, like option C, then what happens? If you increase the temperature, then resistance of the thermistor must decrease, due to which potential difference V should be decreasing. While in the condition they are saying potential difference of the component Y should increase with the increase of temperature. That means this is the wrong position of the thermistor. So thermistor should be attached at X. because thermistor attached at X, this is the correct position of thermistor. When temperature is increased, so resistance of the thermistor is going to decrease, due to which resistance of Y will increase, so the potential will increase. So the option is D. X should be thermistor, Y should be resistor. 33. Which two logic gates each have a high output when both of their inputs are low? Remember, you have a high output when each of the input are 0, and an OR gate. If both inputs are 0, then output is always 0. It is not 1. So AND cannot give you high output, and OR gate also does not give you high output. Meaning for AND and OR, if both the input is 0, there must be output must be 0. So this column is output. For OR is also the same. If both the input is 0, then output is always 0. So AND and OR cannot be your option. So AND, A is gone, and NOR, so AND is involved, OR in D is involved. The remaining is NAND and NOR. So option is C. 34. Two NAND gates are joined together as shown. These are the NAND gate and a NOT. So which single logic gate is equivalent to the combination AND, NAND, NOR, and OR? So the one way, which is of course the long way, you make a truth table for all possible gates, which is you definitely take a long time. But if you remember combination of NAND gate, so you must recall, or if you wish you can try yourself, just try to write the logic gate, and then you have one condition. If you are using only one NAND gate, so one NAND gate is in fact NOT gate. The truth table of NAND gate and the NOT gate is same. If you are using two NAND gates, then it gives you the truth table of AND. If you use three NAND gates, it will give you the truth table or the output as same as OR gate. And four NAND gates give you the equivalent to NOR gate. So if you remember this, then I guess it will be easy for you to give answer for these types of question rather than writing a truth table for each. This is the typical relation between NAND gates and the other single output. So they are saying two NAND gates, so the option should be A. 35. Which components are designed to improve the safe working of a main electrical supply? Indeed, circuit breaker, earth wire, all the three are for safety working for for main electric supply. So option is D. Quite simple question. 36. The diagram shows a current carrying wire placed between two magnetic poles. The current is in the direction of shown. What is the direction of the force on the wire? Again, this is a typical question of force acting on a current carrying wire. The best option is you must use, or you should use, Fleming left hand rule, which is this. So if you see, Fleming left hand rule is you point your first finger toward the direction of magnetic field. That means adjust your left hand in the direction of the field, and direction of the field is from north to the south. So adjust your first finger in that direction, and the second finger should be pointed towards the direction of the current. So second finger should be downward. Then you will find that the thumb is acting downward. That means the force acting on the conductor towards the bottom of the page. So option is A. Try it and see if you can able to arrange your hand according to this situation. Just keep practicing for that things. 37. Diagram 1 shows an AC generator. The coil is turning as shown. AC generator. Diagram 2 shows output voltage produced by the generator as the coil turns. Which point on diagram 2 shows the voltage induced when the coil is moving through the position shown in the diagram 1? So we have a different position A, B, C, and D. Which voltage is going to be produced at the given position? Remember, if you see what is happening at that moment, the plane is perpendicular to the magnetic field, or as the coil is rotating, the coil will be moving. That coil, if you see this coil, will be moving at that moment, something like this rotation. So it will be rotating, but at that moment coil will be moving horizontally. That means the motion of the coil is parallel to the magnetic field. So here's the key: when a coil moves parallel to the field, there is no EMF is induced. So EMF remains zero if the coil is moving parallel to the field. That means at that moment there will be no EMF in the coil. So this position is basically on the graph is B. So your option is B. 38. Which observation provides evidence for the nuclear atom? Attraction of opposite charges, emission of gamma. So scattering alpha particle by a thin metal foil, scattering of course this is a scattering of alpha particle. So option is C. 39. The chemical symbol for uranium is U. The equation represents the radioactive decay of uranium 235. This is the equation for decaying process. What are the number X and Y? A typical question. We have to balance on all the numbers on either side of the arrow. So X should be 235 minus 4, and Y should be 92 minus 2. That means 90, and X must be 231. So your option is B. This is alpha decay. So mass number decreased by 4 and charge decreased by 2. So option is B. 40. An experiment is carried out to measure the radiation from a radioactive source that has a half-life of 10 minutes. The source is placed close to detector that is connected to a counter as shown. Counter this detector. Okay. The average background count rate is 20 counts per minute. This is background radiation. At the start of the experiment, the count rate recorded by the counter is 1000 counts per minute. What is the count rate 10 minutes later? So initial count rate was 1000. So if you need to find the count rate from the sample, because this count rate is include the background radiation. So if you do 100,000 minus 20 will give you answer 980, and after 10 minutes later, the this is a half-life, so 980 is reduced to 490. So 490 after 10 minutes, and then background is already there, so plus 20 will give you 510. So your option is if the option is C, 510 counts per minute. After 10 minutes we have this count rate. So our option is C. Thank you very much and have a nice time.